Okay, this is the problem on thermodynamics. At first, go through the problem. 1 mole of an ideal monoatomic gas initially at 27 degree Celsius and occupying a volume of 10 liters undergo adiabatic expansion in two different ways till the final volume in each case increases to 20 liters. Okay, so what are the case? Number 1, adiabatic expansion against a constant external pressure of 1 atmosphere, and number 2, adiabatic expansion against zero pressure. Okay, so calculate the work done and final temperature in each case. Okay, so for solving this type of problems on thermodynamics, you have to first carefully go through the problem, okay, and find the conditions. Okay, so first condition is, that is, the process is adiabatic expansion. Okay, first process is adiabatic expansion and the data are given, that is 1 mole. Adiabatic means no heat exchange between the system and surrounding. Okay, here number of mole is given 1 mole and the gas is ideal and monoatomic. So at first you have to write the data. You have to write the data, that is here number of mole n equal to 1. Okay, and the gas is monoatomic gas, monoatomic gas. Okay, and here the initial temperature T1 is 27 degree Celsius, that is equal to 27 plus 273 Kelvin, that is 300 Kelvin. Okay, and here initial volume is V1 equal to 10 liters. Okay, now the process is adiabatic expansion. Okay, the process is adiabatic expansion. Okay, so these are the condition, and the first process is here. The first process, number 1, that is the adiabatic expansion against a constant external pressure. Okay, constant external pressure. So case 1 is constant external pressure. Okay, so we have to understand the condition given in the problem. Okay, that is very important. We have to understand the condition. Here the condition is, in the first case, the condition is adiabatic expansion against a constant external pressure. So we know that when the pressure, external pressure, that is P external, is constant, the process is irreversible process. Irreversible process. The process is irreversible process. Okay. So for irreversible process, we know the formula of work done. The formula of work done for irreversible process, we know that formula is W equal to P external into final volume minus initial volume. Okay, that is final volume is V2 minus V1, or you can write it VF minus VI. So that is the work done. Okay, so P external here given 1 atmosphere into V final, that is V final is here given 20 liters minus V initial is given here 10 liters. Okay, so after calculation it is 1 into 10, that is 10 liter atmosphere. Okay, now we have to convert this unit liter atmosphere to calorie. Okay, calorie. So 10 liter atmosphere, that is mean 242 calorie. Okay, we know the conversion. That is the value of R universal constant is 0.082 liter atmosphere, and the value of R in calorie is around 2 calorie. So if we correlate, that is 0.082 liter atmosphere is equal to 2 calorie approximately. So 1 liter atmosphere is approximately 24.2. So to 10 liter atmosphere means 242 calorie. Okay, so in the first case we found the value of work done. Okay, the value of work done. The next question is calculate the work done and the final temperature in each case. So we have to calculate now the final temperature. Okay, for case 1. Now the case 1 is adiabatic and irreversible process. Okay, now we know that W equal to CV T1 minus T2. Okay, at first we have to calculate, we have to at first calculate the work done for case 2. Okay, case 2. Then after that we will calculate the final temperature of each case. So in case 2 you can see that adiabatic expansion against zero pressure. Adiabatic expansion against zero pressure. Okay, so this is a free expansion. So in free expansion we know that, so adiabatic expansion against zero pressure, that is P external equal to 0. Okay, this type of expansion is called free expansion, expansion against zero pressure. Okay, free expansion. So for free expansion we can calculate P external into change of volume. P external is 0, so total thing is 0. So here work done is equal to 0. Clear? Here work done is equal to 0. Okay. Now next we want to calculate the final temperature in each case. So at first, case 1, where the process is adiabatic irreversible process. Okay, so for case 1, W we have calculated, the W is 242 calorie. 242 calorie. Okay, now as the gas is monoatomic, here CV equal to 3 by 2 R. Okay, for monoatomic gas we know that CV is 3 by 2 R and CP is 5 by 2 R. Okay, now for case 1, W equal to CV into T1 or T initial minus T2. Okay, so W, what is the value of W? Or W is 242 equal to 3 by 2 into, what is the value of R? 1.987, or you can take approximately 2 into T1 initial temperature is here 300 minus T2. So you have to find the final temperature T2. Okay, so after calculation, the value of T2 is equal to 218.8. Okay, 218.8. Okay, so this is for approximately you can take, yes, approximately you can take 1.987 approximately 2. So 2 cancel out. Okay, so 242. Okay, you can take 240. So 240 divided by 380. So 300 minus T2 equal to 80. Okay, so it's around 220. So actual calculation is 218.8. So in case 1, T2 equal to 218.8. Okay, now for case 2, for case 2, work is equal to 0. Okay, work is equal to 0 because it's a free expansion against 0 pressure. So as this is a free expansion, so what happened, that here initial and final temperature will be same. Okay, initial and final temperature will be initial on here W equal to 0. So we can write the formula again, that is CV into 300 minus T2. So here W equal to 0. Okay, that means 300 minus T2 equal to 0. Okay, or T2 equal to 300 Kelvin. Okay, so for case 1, final temperature 218.8 Kelvin, and for case 2 final temperature will be 300 Kelvin. For case 1, W equal to 242 calorie, and for case 2 W equal to 0. Okay, so we finally write, that is case 1 answer W equal to 242 calorie and T2 is 218.8 Kelvin. Case 2 W equal to 0 and T2 equal to 300 Kelvin. So that's the answer of our problem. Okay, so this type of problem may be asked in NEET or JEE Main or WBJEE or any other competitive examination. Okay, so you have to think about the problem again. Okay, so this type of problem you have to solve by at first go through the problem very carefully and then write down the data provided and the conditions provided, and then you using the usual formula you can solve this type of problem. Okay.